Okay. So next is mechanical properties of fluid. First, what do you mean by fluid? So you'll say matter with having tendency to flow is called fluid. Matter having tendency to flow is called fluid. So in this part, it will be for liquid and gas both. First, about density. Density is a ratio of mass of substance and volume. Mass is measured in terms of kilogram and volume is meter cube. So SI unit is kg per meter cube. And you have to remember for water, it will be 1000 kg per meter cube. In terms of gram, it will be 1 gram per centimeter cube. So just remember this particular relation to convert gram into kg or unit of this term into this one. Next is you must have learned in class 9th about relative density. That is, relation of density of any substance to water is called relative density. So it will be density of any substance to the density of water, and it will be maximum at 4 degrees Celsius. I will define this part in next chapter, that is thermal properties of matter, how density of a substance would vary with temperature. And this particular ratio is also termed as specific gravity. And since it is a ratio of same quantity, so it will be unitless quantity. Is it clear?
Yes, sir.
Okay, first write it down till this part.
Done, sir.
Mohammed Khalid, you have written?
Yes, sir.
Just
Okay.
1 second.
Sir, what is that after specific?
specific gravity.
Okay, sir. Done, sir.
Okay. So for this chapter, we mainly divide it into two parts. First is hydrostatics, means study of fluid at rest. And next is hydrodynamics, study of fluid in motion. So for hydrostatic part, first is pressure, Pascal's law and application of it. Next is Archimedes' principle, which is omitted from your syllabus. Next is surface tension and its various application. Similarly, for hydrodynamics part, first is flow or type of flow and its various application. Second, and the most important part, is Bernoulli's principle and its various application. So on the basis of it, let's start pressure. Suppose you have a surface like this on which force is applied first along this direction and next along this direction, along this direction, in these three different cases. So in this way, in this middle part, force is perpendicular to this particular surface. So if force is perpendicular over that particular surface, then this force is termed as thrust. So thrust is perpendicular force acting on a surface. Pressure is defined only for this particular thrust or for force which is perpendicular to that surface area. So pressure is the thrust acting on surface per unit area is called pressure. So pressure equals to thrust divided by area of cross section. It is a scalar quantity. There will be no direction. Having SI unit is Pascal or Newton per meter squared. Is it clear?
Yes, sir.
Okay, just write it down. Minashi, any doubt?
No, sir.
Muhammad Khalid?
No, sir.
Okay. You all have written?
One second. Done.
A force of 5 Newton acts on a pin to inject it on surface. If area of its tip is 0.2 mm square, find pressure exerted. Just use the above formula. In this question, we have force and area of cross section. Just put these values in this above part to find pressure. Sham, just check your calculation.
Yes, yes. I put +6 instead of -6. No, sir, thermometer.
Mazia, is it difficult to solve?
No, sir.
Good, Minashi. Raza, send me your answer.
Yes, sir.
Ehtisham, check your calculation. Pressure equals to force divided by area of cross section. Force is 5. Area of cross section is 0.2 into 10 to the power minus 6. So if you remove this decimal, there will be 10 in numerator. So this 2 will cancel out this in 5 times. 5 into 5, it will be 25 into 10 raised power. This minus 6 on moving to numerator, it will become plus 6. And if you write it in decimal, which means you are moving decimal from this point to this point. So on moving decimal from right to left, exponential will become plus or increase by plus 1. So it will be 2.5 into 10 to the power plus 7 Pascal. Nabila, is it clear?
Yes, sir.
Sham, is it clear?
Yes, sir.
You all have written?
Yes, sir.
Next is we have to define for fluid. So pressure exerted by column of liquid. This particular pressure is also called gauge pressure, denoted by Pg. Suppose you have container in which liquid having density rho is filled up to this point. So to calculate pressure at any depth h, let a segment like this is cut out. Having height of column h and area of cross section of base is A. Density of liquid is rho. Consider a cylindrical column of liquid having height h, area A. So for a pressure, we first need amount of force exerted by this column of liquid. So first is force exerted by the column of liquid. Force equals to mass times gravity. Mass is equals to density into volume. Density of liquid is rho. Volume of this cylindrical segment will be area into height. So it will be rho AH into gravity. Nabila, is it clear?
Yes, sir.
Now we have force and we have area of cross section of piece. So pressure due to this column will be force divided by area of cross section. Force is rho AH into gravity divided by area A. This A and this A will cancel out. So you will get rho GH. This pressure is due to this column or vertical column of liquid, which is also called gauge pressure, rho GH. Mazia, any doubt?
No, sir.
Okay, just write it down. You all have written?
Yes, sir.
Minashi, any doubt?
No, sir.
Okay. Using this formula, which is depending upon three different terms. First is density of liquid. Next is gravity, unit acceleration. H is vertical column of liquid. There is no any direction in which this pressure is acting, or there is no anything in this particular formula to define amount of liquid or volume of liquid. So you will say this pressure is independent of direction and also independent of amount of liquid. Which means, suppose there is a container in which liquid is filled up to this and at same vertical column, let's say this level from this, pressure along any direction in vertical direction, along right side, along downward direction, or along left side, P1, P2, P3, and P4 will be always equal. I will prove this particular term. This is consequence of Pascal's law. Okay. Raza, any doubt?
No, sir.
Okay. Let me define you another example for amount of liquid. Suppose you have connecting tube like this. All are connected to one another. And you start filling liquid from any one of them. Let's say from this end, liquid in each container, irrespective of its shape, will be at same vertical height. It means vertical column for each segment will be same. So if you calculate pressure at this end, P1 equals to P2, P3, P4, and P5. It means it will independent of amount of liquid present in that particular container. It just depends upon amount of liquid or vertical column of liquid placed over that particular point. Is it clear?
Can you repeat?
So if you compare amount of liquid in these different connecting tubes, you'll see in first column, there is maximum amount of liquid present in it. And in this fourth column, that is vertical column, minimum or least amount of liquid is present here. But since vertical column for each segment is same, so pressure at same horizontal level will be equal in all cases. So it will be independent of amount of liquid. Pressure only depends upon vertical column placed over that particular point.
Yes, sir. Okay.
Mazia, is it clear?
If the vertical column changes,
Yes,
the
sir.
pressure also changes. Sir.
Okay. You all have written?
Yes, sir.
Muhammad Khalid?
Yes, sir.
Okay. There is one more term in this particular, which is called atmospheric pressure. You must have learned about this in your earlier classes. The pressure exerted by atmosphere or air on all objects living on the surface of Earth is called atmospheric pressure. Pressure exerted by air on all body. So we have to calculate the numerical value of atmospheric pressure at ground level. For this, mercury is taken into a bath or a large container. Like this. This is mercury. And a vertical inverted capillary tube, a very thin tube, is placed into it like this, and which is evacuated, means there is no air inside it. Now, let's say this is point A, this is point B, and this is point C. If I ask you to define pressure at point A, B, and C, so are they equal, or pressure at point each term will be equal or different? Nabila, just tell me, pressure at point A, B, or C will be equal or different?
It would be different, sir.
Why so? Raza, do you have any answer? Why pressure will be different at all these points?
So the middle evacuated one is like closed. The other two are open. So the pressure exerted by air or something. It's closed.
Okay. You'll say pressure at point A will be due to atmosphere or air present over it. Similarly, at point C, there is air above it, but for B, there is no any vertical column of fluid as this tube is evacuated. So there is no air inside it. So there will be no pressure generating material or fluid above this particular B. It means pressure at A is greater than pressure at B. Is it clear?
Yes, sir.
Yes, sir.
Now, so what will happen now? Is there any change or transfer of matter, that is mercury, from one point to other, or it will remain as it is? As we know, land breeze and sea breeze is due to pressure difference and temperature difference. Air blows due to pressure difference from higher pressure to lower pressure, and air is fluid. Similarly, at this point, A is at higher pressure and B is at lower pressure. So liquid or mercury will start rising in this particular tube to some height, this, so that column of liquid raised in this particular capillary tube will generate as much amount of pressure as pressure at point A and C, so that all these points will be in equilibrium. Is it clear?
Yes, sir.
Raza, is it clear?
Yes, sir.
Experimentally, it was calculated the column of liquid or mercury in this particular capillary tube was 76 centimeter. So pressure at point A equals to pressure at point B, and which is due to column of liquid or mercury raised to height 76 centimeter at equilibrium condition. Density of mercury is 13.6 into 10 to the power 3. Gravity is 9.8, and vertical column raised is 76 centimeter divided by 100 to convert into meter. If you simplify this equation, you will get 1.013 into 10 raised power 5 Pascal. And this is equivalent to pressure exerted by air on surface of Earth, which is also equals to 1 atm. Is it clear to all of you? Minashi, any doubt?
No, sir.
So you told pressure A is greater than pressure B. Then you told pressure A is equal to pressure B.
Initially, it was when there will be no fluid in this particular tube, as it was initially evacuated. But later on, due to pressure difference, some amount of liquid or mercury will start rising in this particular fluid, so that to generate amount of pressure at this point B. At equilibrium, pressure at point A and pressure at point B will be equal. The total height raised in this tube will be 76 centimeter. It was experimentally calculated.
Okay.
So the total pressure at these two different points will be equal at equilibrium, and from which we have calculated atmospheric pressure 1 atm is this much, and which is also equivalent to 76 centimeter of Hg. You must have learned about this in your earlier classes, the pressure generated by air on surface of Earth. In this representation, this 76 define you vertical column or height of vertical column. This Hg defines you the liquid used. Just multiply this expression by gravity, you will get pressure at that point. Nabila, is it clear?
Yes, sir.
There are some other unit. 1 bar equals to 10 to the power 5 Pascal. 1 millibar equals to 10 to the power 2 Pascal. And 1 torr, which is pressure due to 1 column of mercury, defined by torricelli, equals to 133 Pascal. Just write it down till this part.
Sir, in the last line, 1 vortex is equal to 1 millimeter of HQ. I mean,
1
Hg.
torr,
Torr. Okay, sir.
Torr.
Okay, sir.
That is short form of torricelli. You all have written?
Yes, sir.
Minashi?
Yes.
Okay. Now, if you add these two terms, that is atmospheric pressure and gauge pressure, it will define you the net pressure at any depth, which is also called absolute pressure. So absolute pressure equals to atmospheric pressure plus gauge pressure. On the basis of this, try to solve question. Find first gauge pressure, absolute pressure at depth of 10 meter in ocean. Take density of water to be 1000 kg per meter cube and gravity to be 10. Try to solve using the above formula.
So if the depth is 10, so we should write minus 10, right? Because it's under.
Yes, Etisham?
So the depth of ocean, 10 meter, you have to write in minus, right? Because it's under.
No. You have to take it as positive.
Okay.
It is a vertical column. This is horizontal level or sea level or level of water. And you have to calculate net pressure at some depth. This. Good, Sham. Absolute pressure. Take this then as height of column of liquid. P is equals to rho density of liquid, that is water. So it will be 10 to the power 3. G is gravity, 10. H is vertical column, that is 10. So it will be 10 to the power 5 Pascal as gauge pressure. Now, if you put the values in this part, P absolute equals to atmospheric pressure, which is equals to 1.013 into 10 to the power 5 plus gauge pressure, that is 10 to the power 5. If you take out 10 to the power 5 as common, so you're left with 1.013 plus 1. So it will be 2.013 into 10 to the power 5 Pascal. Is it clear?
Yes.
Raza,
Yes, sir.
Minashi, any doubt?
No, sir.
Okay. You all have written?
Yes.
1 minute, sir. Done, sir.
Okay, so let's stop here till this part for today. In next class, I will define you Pascal's law and their application, and then we will start surface tension. Okay?
Sure. Sir.
Okay, so I have a question.
Yes.
So in our report card, you mentioned that we didn't submit any assignments. I wanted to ask which assignments were you talking about?
You may ask to Niskarsh, sir.
Okay, sir.
I don't have any information regarding it.
Oh, okay, sir.
Okay. Okay, then we'll continue next class.
Thank you, sir.
Thank you.
Thank you, sir.
Thank you, sir.
Thank you.